Okay, it's recording again now. So when you go to plot this, this is going to come, this data is going to come from your console. So your blade height, or your control rod height, or if you're going to do the subcritical assembly like we will tomorrow, or sorry, Thursday, as you put fuel plates in, you're going to count them, right? So this will be either available from the console, if it's control rod height, you're going to count the amount of fuel that you're putting into something. This will be a given, right? You'll have a source and written right on it, it's going to tell you its source strength. If it's really, really old, you might have to account for decay, but written right on it. So then our count rate is going to go up some amount as we have our subcritical multiplication happening, right? This is where that 1 minus K is occurring. But we don't have to count. We don't have to formulaically get this because we're going to have a detector that will give us some number that goes here, right? I'm trying to show you that behind that count is subcritical multiplication times our source. And then our next step is going to be, you know, maybe this larger amount of subcritical multiplication times the source. And then a larger amount of subcritical multiplication times the source.
So,
but we're not plotting this.
Right. Are you ever going to ask us what the source strength is?
I suppose it is possible that a problem could give you source over count rate and your K,
right, and
ask you to solve for that variable. But I don't find that very useful because you have a known source when you put that into reactor. You will need to understand that you're doing 1 over your count rate as your inverse right here, right? So when you plot this, you just recorded some amount of counts, right? And you put that source over your count, and right here at the beginning, whatever your source is, right, is the amount of neutrons you're going to be able to detect. So you have.
Oh, that's just the number after you divide the source and the count.
Yes. Your value here. Your value here. 0. Let's say this is 1, 2, 3, 4, right? And then let's say this is 0.5, 0.75, 0.25, right? I just made scales, right? So I have inverse counts, and I have my blade height in inches. At 0 blade height, my inverse counts is 1, because my source is all the counts I have, so my source and the counts are the same, right? Then at 2 inches, what's my inverse count? So at 2 inches, I'm at just above my 0.75 mark. And I don't have a straight edge, but if I did, it would do something like that, right? And wherever this crosses, that is where I'm predicting this will go critical.
Can your inverse count? Oh, sorry.
No, go ahead.
Can your inverse counts just be like 0.1, 0.2, 0.3, 0.4 all the way up, or do you want it like?
They could be. They could be.
Okay.
For those of you who are online, let me try to show this. So
this line will go to the negative. It's not like approaching 0. It's just going to be a straight line.
Well, it is gonna approach zero, right? Because this horizontal line is zero, inverse counts.
Yeah,
right?
but is it going to cross zero, or is it just going to approach it?
The formula is just gonna approach it, but we're using a straight edge to actually extrapolate where that cross at equaling zero would be.
What's the formula you're using?
Right now, I'm not using any formula. I'm just using the data table, right? So the data we were given
0 and 1.
is this table, right? I'm telling you that because we have this relationship from this formula, and we know this relationship, when we have a plot of data, this blade height coming from our reactor console, this source strength coming from the label on our source, this count rate coming from a detector attached to our system, we can put the source over the count rate and get this inverse counts, and then we're just plotting inverse counts versus blade height. There's not a formula because all the data has been put in the table in this example.
So then how would we know when it's going critical?
You're going to draw your first line, and then or first data point, then your second data point, then you draw a line through those 2 points, and where it crosses the horizontal axis is where it goes critical. Okay.
I mean, are we, I'm sure this isn't really right, are we attempting to do this? Isn't that the critical point?
Not quite. So this is showing you here on this one. This is what we're doing, the
We're
green
not
line,
doing
not the
both
blue
of
line.
them.
No, we're only plotting one line. Now, see how this isn't a straight line continuously and we've got dots here? That's because the first data point, right,
Mhm,
was our 1 and 0. And then our second one was this point
mhm.
7, 7, and 2, right?
Well, yeah,
Right? 'Cause that's what,
yeah, I messed this up, but
okay.
I mean, it's supposed to look sort of like that.
So then you draw a line through here and you get something down here.
Mhm.
But then on our next slide, we are going to have a next data point, right? So then you draw 1, 2, and now you're going to have at 4 inches a 0.5. Then between these last 2 points, you draw it again. Right?
So I just want to clarify, is it going critical at each blade height, like where the source and count rate is?
No, it's not. This is after we remove the rod a certain amount. Our subcritical multiplication is causing an increase in counts, and we're not critical, but we're approaching criticality. So based on the data, we can make an estimate on where we would go critical. That answer your question, Haley? Do you have a question, Patel?
No, just the slogan, I'm sorry.
That's okay.
I could not, for the life of me, I was so focused on trying to count. This was right.
Yeah,
They're a little off, but I think that's the same, close to 8, very, very close.
very close to 8. It's the first estimate looks like
I know
everyone's
you said this already, but we're plotting the source by count rate or the count rate? The far right, okay. Got it.
Yes.
Do all
So,
these exist on the same line, or is there like a different line for each 2 data points?
Joe, what page number was that?
65.
So if you guys have your Tucker book, on page 65, he has a graph that has an approach to criticality. It has 2 colored lines on it. We're doing the same thing as the green line. And I think that he starts at a much higher number because he's got neutron flux on that side and his withdrawal on the bottom, right? And then his inverse count rate is over on the right-hand side. So that green line reads it has the axis on the right-hand side, those inverse counts and rod withdrawal, okay? And notice that it's not a straight line. But if you were to take your ruler between the first 2 points, it would tell you it's gonna go critical somewhere over here. But then he put in another 2 points. And now it's gonna say it's gonna go critical here. And then another 2 points. So what happens is, we're gonna take the estimate we just made, the graph we just made, right? Let me pull this one up one more time, right? So let's say we had a data point at 1 and 0 and 0.77. So here, let's do it with this color. Here's our first data point, right? And then 0.77 and 2, let's say that's right here, right? If I were to draw a straight line between these, I would cross that axis somewhere over here. And sorry, these are really not straight lines because I'm using my mouse. I apologize, guys. People in class are saying that they're getting about 8 right there where
Yeah,
it crosses.
0.7 or 7.6.
Okay. Now, we're going to refine this, right? This was our first guess because we made one rod withdrawal. So on the next slide, I add another point. At 4 inches, your count rate is 0.51. So if I go back over to my plot, and let's see, I got to put in 4. Try to make this a little straighter. I'm not an artist. We'll leave it. Okay, so now we have a data point that's at 4 and 0.5, right? So it's right, let's say here. Sorry. 4 and 0.5. Now I'm going to make another estimate using my most recent data. So I will draw a line from this point to this point, and it's going to change where it tells me I go critical. And it's going to be more correct now because I have more material in, more blade height removed, more rods inserted, whatever it is. And I have better count data. And you're going to do this every time you remove the control rod or add a fuel plate until your data starts giving you the same answer where you're going to go critical. Joe.
Does this look better? And follow-up question.
Okay, so 2 and 0.7, 4 and 0.5. And then the only thing is extrapolate each line, right? And so your very first one is going to give you a far estimate, and your very second one is going to give you a near
So
estimate.
you wanted the first one straight, the second one straight from there, and the third one?
And what I do when I draw these is I use colored pencils.
So you want me to estimate based on the first point where I think it would go critical?
Yes.
If I drew a straight line and extended it?
Exactly. And then you're going to estimate based on the second set of data. Then you're going to estimate based on this third set of data. Then you're going to estimate based on the fourth set of data.
I get that.
Okay.
Can I show
sorry.
you what I have on here?
Absolutely. Let me enable screen sharing. Or I guess you're probably going to hold it up, aren't you? Yes, Jennifer. Yes. So you'll notice that your first one gives you an estimate somewhere out around 8. It's giving you a far estimate. Your second set of data is going to give you something much lower, and it's giving you your near estimate. And your actual criticality will be somewhere between those, and we'll get closer and closer to the right answer the more data we put into this plot.
Thank you.
You're welcome. Haley, did I hear you have a question?
No, I figured it out.
Okay.
So I show on my plot that it's going to go critical right around 8.
For the first set of data, right? For this red line?
Yeah.
Yes, that's correct. For the purple line, the second set of data, what are people seeing as our estimate now?
Oh, mine was at like 7.
7,
Mine's like 7 or 3
7. Online, that second set, where are you guys seeing?
Somewhere around 7.
Around 7.
The
Okay.
longer your graph is, the like closer your lines are gonna be.
Yes, and if I were you guys, what's gonna happen on Thursday, and we're gonna practice this tomorrow, I'm gonna give you a set of count data and number of rods that we're putting, or fuel plates that we're putting in something. You know how many fuel plates they have at the subcritical assembly, so your bottom scale is gonna be out to dozens of places, right? And so you're gonna take your very first set of measurement data, and it's probably going to give you some critical number at more than the fuel plates that they have, because they have to stay subcritical, right? And so you'll plot 1, and then you'll plot 2, and then you'll plot 3, and there'll be some value between those, and you'll plot 4, and you keep plotting it until your graph has those lines start crossing at the same point. Then your data is starting to tell you, okay, we're getting to the point where our counts are getting close to start being representative K effective instead of M. Okay.
And then you want the, so right after that, just turn in the graph that we've made with the inverse counts.
Yes, I suggest that you have at least one person who is not graphing, whose only job is to make sure that they have recorded the data for each step, so no one misses anything that you share. And then 1 or 2 of you who are graphing each step. And that way you guys can kind of predict how many fuel plates you need to put in the subcritical assembly.
Okay.
And I will be there also. Yes, Joe.
How would I know
I think it's random.
where to extend the line from my first point? Because, I mean, I could manipulate it any old way I want it and call it a straight line, couldn't I? And how-
Because it's the first line.
The first 2?
Yes.
Like if I went like so, that would be, and then I extended it out like that,
Exactly.
but then it would be 8, it'd be way off. Is that just because
Well,
of
I
the
think-
scale of my graph?
Yeah, that, so if you, draw that. Right, yeah, it's like at 11.
Is that wrong, or is that just my estimate?
That's just your first estimate,
All right,
right? And then you're gonna draw here.
this way.
Yes. There's your second one, down by 7, which is what everyone got.
Okay.
Now your next prediction. Here. And that's somewhere close to 8, right?
Okay.
And then your next prediction. Is right there. Between, that one. Those 2. So now you're getting really close.
I see.
Right?
Get more accurate as it goes on.
Let's see how we did that one. Yes. So you did your 1, 0, and 0.77.
Mine was.
Sorry, I can't hear you. 1 second online.
I think that's good.
Just looking at. All the way
Hey,
up.
Joe, I like those boots, man.
That's what Joe got closer to 11.
I know a bunch of people with these lows that are in service.
Yeah.
Oh, cool.
They got like a tactical pair that are like Vortex.
Now this one, you've got.
Yeah, that's why I don't wear these. I have to wear waterproof shoes for work.
Vortex makes your feet hot.
Now
Well,
you're
when
starting to
young,
get close.
When you're
Right?
old, your machine don't work
And
so well.
Yeah, I have, I tried
So
a
at
pair of
first,
Under
we didn't
Armours
have these other data,
for hunting,
right? I only showed you the
and they're
first. Yeah.
Vortex.
That's huge. Yes. So
And
that tells me,
they're-
okay, here,
They're not cheap.
I think I can go
boots,
all the
they're
way
like
up to
150
10.5
bucks.
inches with draw and blade
Put
height.
my foot in them the first day.
Then I take it out another 2 inches.
In the truck. and
Then
kinda
this draws
run it
down.
around with coyotes
Right here,
and
but
stuff.
oh.
Not a lot.
Well, now this is only telling me I have to go about 7.5. So somewhere
Just
between
at
you
the
can only
Under
pull
Armour,
out
they
your
have like a fitting membrane in there that it's kind of like a Dr. Scholl's type.
And
of
we know,
deal.
because we're gonna keep doing
In
this,
there.
that the reality is the
Their
answer's gonna end up
vortex too,
somewhere
they
between the
get
first and
those-
second,
I first started on Vortex when I was about your age.
right? So then we do it again,
I
and
heated
we
in the
don't-
car.
now we're close to
my
8.
feet.
Yeah.
And I'd have
And
to
then this one
dance
here,
my
if we
feet
can do
around.
that, oh,
Well,
we're really close to
Oh,
8.
yeah.
Yeah, it's
Somewhere
not
around
like
8
that
is getting
anymore.
close to the right answer. And then we just keep going,
Well,
step
I
by
like the
step,
lowest, their
until we
version of
reach
that are really
critical,
nice.
right?
know
And
a
that's
lot of
when
people
our
use them 'cause they're
estimate ends up in the
comfortable,
same.
they're waterproof. I went through,
Does that make
so
sense?
I went
Because
through
our data
special forces selection,
doesn't
where you go through
continue
and do a
subcritical
little
meditation,
meditation,
it's the
trap,
same
and
process.
a lot of people were.
Now we're in our
I like
critical
it.
neutral meditation.
They must be legit, and then I
Yeah,
tried them
yes,
on
I
and
can.
walked around the woods and
I was using it.
they're cool boot for sure.
Do you-
I like those, I like a lot of them
Could we have our?
for like outdoor shoes, camping shoes, I like a lot of like,
Okay, so,
well,
Erase
some
these and
people
that
are
one.
coming out with great like hiking shoes.
Anybody online
Some
have a
people
question
like mountaineering
on what we did?
shoes.
You guys ready for the next data point? Right, so go ahead and plot. Okay, so your first data point is here, right? And your second data point is 2 and 0.77. So the first thing you're gonna do is you're gonna connect this dot and this dot. And you're gonna draw all the way to the vertical axis. Right? Right. So some number up there. Now, what's your next data point? No, those were our first two. What's your next one? So that's at 4 inches and 0.51. Now, I'm gonna connect my two most recent sets of data. Draw this line
My
all the way
line
to
didn't really change,
the right from the data point.
my line didn't really change, kind of stayed on the same.
Yeah.
Okay, now somewhere between wherever this hits, at 10 or 11 or whatever it is, 7.5, that's where you're gonna go critical. So now, we're gonna say, okay, I can go from 4 to 6 inches, and I'm nowhere close to that. So what's our next data point? And. So draw.
I get where we're going with this, but my lines didn't change, they kind of stayed on the same little
So
line.
now your two most recent sets.
I
I was hoping that maybe there'd be more of a dramatic.
think it will, I think
They're
it's
talking
supposed,
the axis.
Well, mine's like
Right?
long.
Okay,
yeah, mine is too, it's
Now,
not change very.
we're gonna do
that's
one
what
more
I'm
set
saying.
of data,
I
and so
think
you're connecting each of the most recent
tighter
sets.
your
Oh, you better
horizontal
not
line
see
is,
it.
and then the longer your
0.125.
inverse line is, it's gonna offset it a little bit, give it more like direction. Where ours is longer, I think it kind of like,
And it's
you know what I mean, it stretches those lines out, so it's not so tight.
0.125.
But if that baseline horizontal line was more, you know, adjusted, it would have to drop, you know what I mean?
You're definitely seeing close.
If your stuff was tighter, yeah. More pronounced.
What would you do here?
So you're always taking the point that you, like your last point and the point, and then going to
Yeah, you're making your lines from the two
I
most.
mean, we would have
recent
been fighting.
Yeah.
About it, for sure.
Okay, and one more set of data. So when I moved from 0 to 2, this was our very first movement with the rough blade, right? I didn't know where I was gonna go critical, but I'm assuming 2 inches compared to the total movement of this blade is a small amount. Then our first estimate, depending on how well you drew your scale, you got somewhere between 8 and 10, right? Well, the move to 4 is still really conservative compared to even our lowest estimate of 8, right? I'm not close to critical. I'm not even halfway there yet. Then we had an estimate somewhere between 7 and 8. So moving from 4 to 6, I'm getting close. So I'm still okay. But then our estimate still is hovering between that 7 to 8, right? So notice this movement is now much smaller as I'm getting closer to criticality, because I don't want to exceed it.
So if our plots, I mean, you can look at mine, for example, like from 2 to 7, that new line, it was just barely different. And
Yes.
then it honestly stayed on the same line just because of the way I have my graph drawn out. Is that wrong? Do you
Nope.
want to see the,
Eventually, your line is going to be the exact same because that's where you're critical.
okay, that's it.
Do you ever use these, like, in the opposite, like, not startup, but going from super critical to critical?
No, we don't use these backwards. Okay, I know I've run overtime just a little bit. Here's one that was just using the equation I got from the very last step to show that somewhere between 7 and 8 is what our final answer should have been. Yours will have little steps, but Excel doesn't let me make that look pretty. We are going to do this again tomorrow, so if you're still feeling a little lost, don't worry. We'll practice it again and make sure we get it. Any questions before I end the video? Okay. Those of you, if you were having trouble following this online, you might find it helpful to be in the classroom tomorrow because I was able to look at everyone's graph and kind of show them. So if you want that help, be in class tomorrow. And then on Thursday, class is at the reactor and you do need to be present for that.
And Thursday, that's at what time? 10?
8.
That was it.
8.
It's class time. Yeah.
I like that.
All right. See you guys tomorrow.
Is there
Oh.
a equation that tells us where we're supposed to be on the graph?
I'm sorry, Sam. I couldn't quite understand what you were saying.
Is there an equation that tells us where we should end up?
No, because you're just relating the counts you keep finding to where K effective might end up. It's not, the equation of that line is going to change each time you get more data, right?
Right.
So it's not like we're just plotting an equation. We're actually plotting raw data.
Okay.
All right. See you guys.